Lastly, when it comes to horizontal asymptotes, I wanted to discuss some functions like some trig functions or exponentials or this sort of thing. Because, as you know, if we look at the long time behavior, for example, if I ask you what the limit as x goes to infinity of cosine of 6x is, well, you know this doesn't exist, right? Because this thing is just wiggling. However, if I ask you for the limit as x goes to infinity of e to the minus x, then we know that e to the minus x is going to 0, right? So it's okay for something like this just to write that without more detail, because you really are, it's just, we have talked about that plenty of times. We know that that's what the function does. So in a situation like that, what are you going to do? But what happens if we've got limit as x goes to infinity of e to the minus x cosine 6x? Well, if you were to graph this, you would see that it does actually do, I'm going to graph it here, it does that, right? It's wiggling back and forth, but the e to the minus x is taking it down. Okay, so from a graphical perspective, I can show that that's equal to 0. From a point of view of wanting to show it really more strictly, you could use the Squeeze Theorem, because you can use the Squeeze Theorem as x goes to infinity, as long as you're being squeezed by some two things which are going off to a specific limit. So you could do that. I wouldn't necessarily ask you to do that, for example, on a test or anything. But that is how you would do it if you wanted to be properly careful about this. What I wanted to do rather than that is sort of talk about some other ones, really just kind of quickly, a couple of quick examples. Stuff like this, as x goes to 3 from the left of inverse tan of 4 over x minus 3. Okay, as we know from continuity, I can take this limit into there. Limit as x goes to 3 from the left of 4 over x minus 3. Okay, now what's that doing? If I do a sign chart, here's 4 over x minus 3. Okay, if x is smaller than 3, I have something negative. If x is bigger than 3, I have something positive. So here I'm over here. I know I have a vertical asymptote because I'm basically getting to 4 over 0, but I'm going down to the negative side. So essentially what I have here is like the inverse tan of minus infinity, which I don't want to write. That's not right to write things like that, but you know, whatever. So you can imagine, but what is inverse tan looks like? It looks like this. So the horizontal asymptote on the left-hand side is negative pi over 2. So the answer here is negative pi over 2. So what happened was I pulled my limit in, then I did this limit, which is a simple, so it's a simple asymptote. All I have to do is make sure that I have the sign right, okay? Because the sign will change the answer here. If it was the other way, if this was a plus, this would be plus, that would be plus, right? So it matters. But essentially, this is the same process that we would do if the limit here was finite. Okay, so I have one more, I think, to show you. Let's see. Also with a natural log, right? So here, limit as x goes to 2 from the right, 3 over natural log of x minus 2. Okay. Now, what does natural log do? Of course, natural log of 0 goes towards negative infinity. And if I'm sticking this guy in there, this bottom is going to negative infinity. So if I look at that, actually this is what my 2, right? 1, 2, boom, boom. This is natural log of x minus 2. So the 3 just goes along for a ride. I'm going from the right, so this is perfectly defined, but it is approaching negative infinity. So this is essentially like this. So this is this is just going to go to 0. Now I hate to write this, that doesn't really make sense. But really what's happening is this is going to 0 because I'm dividing by progressively larger and larger numbers. Okay? So you can think about this very similarly like you would have 1 over x or something. We talked about 1 over x, we talked about 1 over x squared, all these things. Where they have an asymptote, the asymptote is going to positive or negative infinity. So then you end up with the value of 0. Right? So this is just that kind of behavior. So you can see that here as well. I think I've now covered like an example of everything, but I might have forgotten some, so I might add more videos later.